Hello and hi everyone, my name is Nur Atira binti Razali and my registration number is 01DKA20F2002. And today I am here with my team members, which is Edli Edliza, Shafi Azam and Hazim Rizal from DKA3A. We would like to present a topic of Atterbergs Limit test. So before we start our presentation, we would like to express our gratitude towards our beloved lecturer, Puan Norasia, for giving us the chance to be here today. It was such a great pleasure for us to be here today to discuss the topic that we have prepared to present to all of you. So without wasting any time, let's start the presentation. Okay, now I'm going to start this presentation by introducing to you what is the Atterbergs limits. Okay, the water concentrations that defines transitions between the solid, plastic and liquid forms a specific soil type are known as Atterbergs limits. The tests are only applicable to cohesive soil with a significant slit or clay percentage, and they can't be done on sands or silts with a high sand percentage. Detailed mineralogical studies of cohesive soil have revealed that Atterbergs limits are strongly linked to clay concentrations and clay mineral species, and hence to the climatic and geologic conditions that prevail during depositions and the post-depositional weathering cycle. Okay, so the objective of this test is to determine a liquid limit and plastic limit and to classify a soil samples. Okay, so now I'm going to share with you some of the theory of Atterbergs limits. Atterbergs has introduced soil characteristics into three types, which is the first one is liquid limit or known as LL. The liquid limit is the empirically established moisture content at which soil passes from the liquid state to a plastic state. Next is plastic limit or known as PL, where moisture content when soil change from semi-molid to a plastic state. Okay, and last but not least, Atterbergs limit has introduced us to a shrink age limit, where soil is state where the density doesn't change even when the moisture content is reduced. Okay, so that's all from me. Next, I'm going to pass this presentation to Hazim Rizal.
Apparatus for Casagrandes methods. For the first one is Casagrandes, used to determine the moisture content at which clay pass from plastic to liquid stage. And for the second one is moisture content metal container, used to enough amount of soil. Later, the cone will penetrate the soil for 5 seconds. For the third one is porcelain sets containers, spatula and distilled water. Porcelain is an excellent and very practical material for microwave or ovens. Fourth one is SIF number 36 British standards, a device for separating wanted element from unwanted material, or for controlling the particle size distribution of a sample. For the fifth one is flat glass plates, useful for variety of general laboratory applications such as medicine surface. For the last one is electronic balance, used in the accurate measurement of weight of materials.
Okay, next we go to procedure of Casagrande method. Okay, the first, after thoroughly mixing the soil sample, fill the Casagrande bowl with the sample while the bowl rests on the base. And second step, level of the soil surface parallel to the base. Next, using the grooving tool, divide the soil in the bowl along the central line by holding the grooving tool normal to the surface to the bowl. Next, check to see that the underside of the bowl and the top of the rubber block of the Casagrande device are free of water and soil. Next, turn the crank at a rate of 2 revolutions per second to lift and drop the bowl. Next, count the number of drops until the groove closes in to about 10 mm in length from the bottom. And the next step, using the ruler, measure the length of the groove that close or join, and the soil is said to be at its liquid limit when this length is about 10 mm after 25 drops. And Next, when this requirement is achieved, obtain the moisture content of the sample and place a sample of the wet soil in the tin cup and obtain its weight before drying in the oven.
Thank you. Hello everyone. Before I continue this presentation, allow me to introduce myself. My name is Eli Adliza binti Jafridin. My metric number is 01DKA20F2011. Now I'll explain about the Casa Grande methods, data and calculation. Based on the data above, for the liquid limit we test using the Casa Grande method, we obtain 4 different data. Moisture content for the first testing is 23.06%, the second testing is 24.43%, the third testing is 27.39%, and the last testing is 30.69%. After that, we plotted the moisture content graph to find the liquid limit. The liquid limit is 22%. For the plastic limit, we test using Casa Grande method. After we tested all 4 samples, we obtain an average moisture content of 15.02%. After that, we have calculated plasticity index of 6.98. From the graph, we found that the soil classification is silt low plastic. The importance of the liquid limit test is to classify soils. Different soils have varying liquid limits. To find the plasticity index, we need to know the liquid limit and the plastic limit first. That's all for Casa Grande method. Moving on to the next part, which is cone penetration method. Now I will explain about the apparatus. There are 8 apparatus that we needed in this experiment. Starting with liquid limit device, it is used to determine the moisture content at which clay soil pass from a plastic to a liquid state. Next, moisture content metal container. It is used to put enough amount of soil, later the cone will penetrate the soil for 5 seconds. Third, flat plate glass. It is useful for a variety of general laboratory applications such as mixing surface. Fourth, electronic balance. It is used to accurate measurement of weak material. Fifth, porcelain set. It is used to put the soil sample inside. Spatula. It is used to make the soil sample. Distilled water. It is used to add into the soil sample. And last but not least, drying oven. It is used to remove moisture from the oven to dry sample as quick as possible. That's all from me. The next person will continue this presentation.
Okay, next we go to cone penetration method procedure. Okay, the first, sieve of dry soil pass through test sieve, and the second, place about dry soil pass through test sieve, and the next step is adding the distilled water and start mix the soil with the spatulas for at least 10 minutes. And next, place the portion of the paste soil in the cup and press the soil. Pass again in the side of the cup to avoid trapping air and make sure the top surface is finally smooth or level with the rim using the straight edge. The next, lock the cone and shaft unit near the upper end of its travel and lower the supporting assembly carefully. Next step, lower the stem of the dial gauge to make contact with the top of the cone shaft and make sure the tip of the cone is within a few millimeters from the surface of the soil in the cup. And the next step, press the button to allow the cone fall and wait for 5 seconds. And next, record the dial reading to the nearest 0.1 mm for R1 and lift out the cone and clean it carefully. And next, repeat step 5 for reading R2 at least 2.41 sample and record the dial reading to the nearest 0.1 mm for R2. And next step, take the moisture sample from the area penetrated by the cone into the moisture can and weigh the empty container and moisture content container and repeat the same step to get value for R3 and R4 and also take the moisture sample. And lastly, put into oven and let dry for 24 hours. And the last step, weigh the moisture content after 24 hours. And that's all from me. Thank you.
Thank you, Shafiq. Now I'll explain about the corn penetration methods data and calculation. Based on the data above, for the liquid limit we test using corn penetration method, we have obtained 4 different data. Moisture content for the first testing is 48.86%, the second testing is 51.71%, the third testing is 60.69%, and the last testing is 46.25%. After that, we plotted the moisture content graph to find the liquid limit, and the liquid limit is 45%. For plastic limit, we test using the corn penetration method. After we tested all 4 samples, we obtained the average moisture content, which is 43.61%. After that, we plotted the graph of plasticity chart. We have calculated the plasticity index of 1.39. The soil categorization is seed low plastic. According to the graph, the liquid limit test is useful for classifying soil. The liquid limitation of different soil differ. To calculate the plasticity index, we must first determine the liquid and plastic limits. That's all from me. Thank you. Now Hazim will continue this presentation.
For discussion, this testing method, also known as Casa-Grade method and the combination method, it used to describe fine grain fraction of soil and specific the fine grain fraction of construction material in numerous engineering categorization system. Liquid limit, plastic limit, and plasticity index of soil are also used widely to correlate with engineering behaviors such as compressibility, permeability, compatibility, shrink well, and shear strength, either independently or in combination with other soil parameters. The liquid limit test is useful for classifying soil. This soil limitation of different soil differ. After plotting the graph, the liquid limit obtained using the Casa-Grade method is 22%, while using the combination method is 45%. Whereas the plasticity for combination method is 6.98 and Casa-Grade method is 1.36. The soil qualification for both of these slid low plastic because both are less than 7. In conclusion, we were able to determine the percentage of liquid limit using the combination test. When using a panometer, make sure the tip of the cone barely contact the surface of the soil sample to achieve an accurate reading of the depth of penetration. Ensure that it does not sink even a fraction of an inch below the surface of the soil sample. Scientists will alter the penetration reading. The plastic and liquid limit of the soil sample may be calculated using the British soil classification system, with the soil sample being categorized as clay with low plastic based on the liquid limits and plastic limit. Value obtained using the Atterbergs limit test. Using the Casa-Grade device, the Casa-Grade technique has also been used to determine the liquid limits. This is due to the fact that each soil has distinct liquid limits. The number is critical for calculating the plastic limits using the formula P L and LL minus PL. Okay, that's all from our group. Thank you.